Three.
Well, good afternoon, everyone. Welcome to another episode of the Three Amigos. Today, we have an exciting new addition. We're going to start bringing in successful entrepreneurs that we know intimately that have made an impact in their community, and in this particular case, right here in the Inland Empire. And so it'll be Ron, Ed, and Wally Brithinee who will be working with us as we move forward. I'm going to begin by letting Ron introduce Wally, since he and Wally have had a long-term working relationship. And with that, I'm going to pass it on to you, Ron.
Well, thank you, Ray. It's really fun to be able to get together with someone that I know so well, who's become a good friend over what did we figure, Wally?
20 years.
15, 20 years, something like that we worked together.
Yes, I was there.
Somewhere in the late 90s, I think, when we got started. So
right.
It's fun to do. And it was fun to reminisce, to go back through and try and pick some pictures. And all the work we've done over all that time, I mean, the quantity is just massive. And so I just picked, 4 or 5 brief shots just to give, our viewers a little bit of a sense for what you're about there and what it kind of looks like. So Brithinee Electric, raising the standards, has been sort of the moniker. And that came from an awful lot of work in ESA, which is the organization that most motor rewinding facilities belong to, among a few other kinds of companies that are related into that. Wally spent years and years and years working on the standards for the industry on how you do this. And I mean very technical standards. So it was kind of a natural thing to do, is to use raising the standards. And in fact, the interesting thing is that in the motor rewinding and the motor controls business, there weren't as regimented, I guess, or standard practices as maybe there should have been, or you might have expected. And so Wally was very instrumental in helping set that. And the company over many years utilized those standards as a way to increase quality, which kind of starts the story off a little bit. Ray is going to have some questions that'll cover some of these, but I'll just mention briefly that Wally and his twin brother Don's got started in the business even when they were in high school. Their dad, with their father and mother, started doing repair work way back in about, was it 64 or 5? So a long time ago. And they went through school, did well in school, went on to college. Both got their masters and PhDs in mathematics. And so that tells you just a little bit about the kind of technical expertise and some of the engineering aspects that they injected in the business over the years. So they are in a kind of a business that deals not with little teeny motors, but with humongous motors. And these are like a whole different thing than you would expect, because most consumers don't ever run into these big behemoth things that just have, thousands of horsepower. They're big, they're heavy, they've got a huge amount of copper in them for the windings, and both motors and generators. And the interesting thing is that until you start looking at this industry, you don't realize that we would have nothing if it weren't for motors. Sure, we could have electric lights and a bunch of little toys, but manufacturing wouldn't exist as it does today, for instance, if we didn't have electric motors. Refrigeration wouldn't exist. There are so many things that we depend on really large, sophisticated motors to build. And so here's just an example of one of them. A big motor doesn't start and stop because they're so big and they're rotating so fast that if you just turn off the power, they literally can break the motor. They can damage the internals of the motor, or and as a result, you have to have these complicated control panels that are. This is just a teeny section of a control panel that slowly start these up and get them at optimum speed and do a bunch of other things that I can't speak to. And they had a whole control panel shop that did nothing but just sell big controls for big motors. Because they were specialists in motors, they knew how to do a really good job in controlling those motors. About halfway through the time when we worked together, Wally decided that they had moved into big wind business and other kinds of big generators and motors, and they needed to increase their crane capacity. And this is an example. One of the first days, I think, when the new plant was up, and we were trying to promote the new building, I think. But this was just the addition. This is not the whole building. This is just the addition of the large shop. To give you a sense for how we tried to market it is that we did it all in a very professional way, because the standards that were set by Brithinee really created a whole new class of quality that we called Brithinee quality. And only Brithinee could really make Brithinee quality. And we used to say that we have a near zero failure rate. And then in parentheses, we say, oh, we're still waiting for the first failure. So it was an incredible level of quality that was able to come out of it. So we marketed it as, it's an industrial company, but we marketed it as a first-class, high-end, and it was more costly. And so we had materials that looked a little like this. This happened to be one that I found that was just a 4-page brochure that kind of showed the layout, just to let people know, here's the whole plant up in the upper left, so you can get a sense for what the plant, and it doesn't include another building that is over underneath the map here, which is where the control department was. And then after spending a half century in the business, having done some teaching and then coming back to work, and of course both of their parents did eventually pass on, then the two of them continued to build the business for many years. And then what happily happens is that eventually somebody will buy a really good business. And we talk a lot about that, the Three Consulting Amigos, and we know how difficult it is to actually sell a business, let alone at a nice price. So we can kind of say that this particular photo here represents the completion of careers and the completion of the sale of a business. This is on the right is Don Brithinee, and you can see how similar the two of them are. Tell us a little bit about this last day and the new buyer, Wally.
Okay, this is on the left in this photograph is a fellow named Jim Mugford, and he's the president of the division that bought us of the company called Sulzer, Sulzer. Sulzer is a Swiss company that began in 1834. So when they purchased us was 2018, and at that time we were 55 years in business, but Sulzer was 183 years in business. Maybe some of the things that Sulzer did and again, it was based in Switzerland, was to manufacture locomotives. They had an engineer by the name of Rudolf Diesel who developed the diesel engine. They made a lot of very large hardware for ships, for railroads, and then they made boilers and large facilities type or utility equipment. If I were to say, while our shop has cranes that would handle 10 tons and 20 tons, the products that we thought were at the high end of what we worked on in size. So when you're looking at motors like the one photograph that Ron had put up there was maybe 5,000 horsepower or 7,000 horsepower. That actually would be a small product for Sulzer to service. And they're not a well, they do manufacture motors, I suppose, for one of their divisions. But in general, they don't consider themselves a motor manufacturer. They're a pump manufacturer, they're a turbine manufacturer, but they're not really considered a motor manufacturer. And but in terms of service, they're the largest in the world. They have facilities all around the world, and that is that's a repair service, but on really large items. So in the fit between our company, Brithinee Electric, and then transitioning to Sulzer, there would be a bit of a change, because we serviced a lot of smaller equipment. We had customers that we considered good solid customers that would, but the product might. It's hard to say what they'll do with that mix of business. Because their focus tends to be on really large items.
So that begs a question, Wally.
Yes.
You know, you showed us an engine, or at least Ron did, of 5,000 to 7,000 horsepower. And you said that's small. Can you give us an example of what is really large and how motors fit into that?
Well, the water. Okay, whenever we would do motor classes, I would usually ask for a show, and our audience was mostly water industry people. Let's say we were doing a class for Southern California Edison at one of their facilities for water customers. I would ask, how many of you have ever seen a 1,000 horsepower motor? And almost nobody raises their hand except for a certain group. That was Metropolitan Water District. Metropolitan Water District has motors in the 80,000 horsepower category on the aqueduct.
Yeah, that's almost unimaginable, isn't it?
And then you get the very largest. I had people on my committee, engineering committee, that were involved with Air Force facilities. Probably the largest motors in the world, or at least in the free world, are on wind tunnels for aircraft component testing. And they described some really huge facilities. And I got to say, I did not hear what horsepowers those would be. Now, to give you an example of horsepower and something else, okay, in my backdrop, I'm showing that from my home in San Diego, or in Coronado. Coronado has a big Navy presence. The Navy, back in the year 2000, they were working on all electric aircraft carriers and nuclear submarines. And the propulsion motors that they were discussing were 25,000 horsepower.
Wow.
So that an aircraft carrier would take 25,000 horsepowers, and a nuclear submarine would take 25,000 horsepower. Yeah. And those were direct drive into the propellers. So their speed would be 25,000 horsepower at say 100 RPM. Now, wow, those are pretty large machines, but industrial. So the military needs, though, are for compactness and weight reduction and space reduction, where industry, which would have something like that size, is the machines can be bigger. You don't have a real estate issue when you're working with those kind of machines. So certain industries would have motors and that horsepower. But
what was the range then, Wally? Give us a sense for what Brithinee Electric did. What would be a reasonable small motor and a big motor in terms of horsepower for Brithinee Electric?
Yeah, for Brithinee Electric, there is no small. Unfortunately, it's too small. But let's just say a 1 horsepower would be, or fractional horsepower would be there are motors that are called sub-miniature motors, so they're really,
Yeah.
really small. We couldn't handle those. But a plant you have to keep in mind that if a plant has a 1,000 horsepower motor, it's probably got 100 horsepower motors in the plant and 1,000 10 horsepower motors. So
Right.
so there's a wide variety, but our coverage would have been, let's say, from 1 horse through 5,000 horsepower.
Yeah.
And we viewed that limited by the testing capability, because when we wrote the standards back in the 90s, that one of the things that we helped to put in, this is the industry standards that became the ANSI standards. So they are the standard for the United States. The testing, the requirement for a repair includes testing and run testing. So to just, one could assemble a large piece, but you had to be able to run it too, and run it at full voltage preferably, because certain your final test measurements, which are required in the standard, also it takes a lot of power to run, say, 5,000 horse. So when we sized the expansion, it was for 5,000 horsepower. Wow. The other thing that was a factor was wind generators. And in the state of California, the largest wind generators, according to the people we dealt with in the wind industry, would probably be 3,000 kilowatts. 3,000 kilowatts. That's 4,000 horsepower. And so, the 5,000 horse, we wanted to be able to handle the largest wind generators. Now, when you read in the news that wind generators are going to be placed off of Cape Cod, let's say, and when you get into these wind generators over the sea, or the North Sea area, let's say in Europe, you can get into 12,000 kilowatt machines, much bigger than what we'll ever see probably in California for wind generators. And
now, if I can interrupt you here, Wally.
Yes.
How did you guys get into this? Because we know that the two of you actually graduated together at 21 years old with doctorates in math. What brought you back to Brithinee, and why not some other field?
Well, we had been investing quite a bit of money back in the 60s and then the 70s in the business. And when I say investing, we built a plant in the early 70s and we paid for it as we built it. So it was paid for the day we opened the doors, as far as the building goes.
This was your father, or you and Don?
Well, all of us. We were equal partners, basically. We were equal partners, and there was this, and it was making money. That was the other thing, and it was exciting. To be truthful, the business side, I have to say, versus academic work, was much more. It had a daily, what I call a daily satisfaction with what you accomplished. Where working in math research was, a year to get a success. I mean, it was that compared to every day. And so the business side was far more appealing, and it was a matter of trying to do both. And then when the time came, it was like, hey, money from a monetary standpoint, the business was doing well, and it was a lot more than what you would do with just the academic side.
So they beat your professor's salary, is what you're saying, or you beat your professor's salary in terms of money that was being made.
Right. Yeah. And I'm not trying to say that as to brag at all. It's just that you had a chance in your business to kind of, like, the more you worked, the more you made. That was another factor. Whereas in something, let's say, like working at the first job I applied for after I got my doctorate was at Cal Poly Pomona, and I did not get it. The professors that I was interviewed by were saying, well, hey, we don't do research out here, so you're probably not going to be happy if you're not doing research. And I'm saying, well, I can live without doing research, but I really, my heart was not really into like going to work as a professor. To be honest with you, it was.
Yeah.
Well, you obviously, Wally, the entrepreneurial bug got you well before that when you were working with your father. So now we understand you're equal partners. Help us out a little bit, because basically I think you were responsible for the motor winding and Don was responsible for controls. How did you guys make that decision? Or
that wasn't exactly how it went, but
okay.
we had hired a fellow in 1980 who had been a instructor at a community college, but he had also been in the pump business. He had what I call a teacher personality, meaning he liked to teach. This is something that is, to me, really a valuable person to have around. And so he helped to put together the machine shop in our place. And then he launched into the control side. Now, the control business, and when I say launched into it, I'm talking about designing small panels.
Right.
What happened in 1982 was that Toshiba produced the first microprocessor-based variable frequency drive and it had a reliability that was far and away better than anything else had been on the market to make motors operate at variable speed. The motors, when you see a picture like the one Ron showed, that particular item, if you ran it as a motor, would run at a single speed, let's say. Let's call it 1800 RPM or 1200 RPM, let's say, one speed. And then the electronics can be used to make that run at variable speed.
Okay.
But up till 1982, the methods of controlling speed were really poor. Lots of failures, short meantime between failures. I mean, the electronics failed a lot. So what happened with that product when 1982 came, the control business for us wasn't very exciting until that time. And then all of a sudden you had this electronics that was very valuable and it was pricey, 10 times the price of the motor it controlled. And so it was.
I didn't realize that. That's just amazing. I didn't know it was 10 times. Wow.
Yeah, but the size, I mean, everything as we know gets smaller and smaller. And of course, we were not anywhere near yet to what Apple did with a cell phone, and all. But we were a lot closer. So prior to that, the electronics for even a 5 horsepower motor would fill a cabinet 90 inches high. When you got to what 1982, that came down to something that was more like 15 inches by 15 inches by 8 inches. Okay, and reliability was years between failures, not where. So that just dramatically changed that thing in the marketplace. So now you had a chance to do variable speed applications, and that's what we got into. We entered the golf course irrigation station business. We built panels for that, and these revolutionized. That would be what the Department of Energy would call a market transformation, which brought about energy efficiency and reliability. And the key was you had to deliver both. And so anyhow.
And let me just interject there, because that's sort of a market change in how that particular industry evolved, which, is one of these industries would say, well, that's, 19th, 20th century technology. But in fact, by the 80s, it was already beginning to innovate. And this innovation, even though you're talking about a motor that has been built the same, the features are the same as they were back when General Electric did the first 3-phase motor, but the the apparati that control those motors have gone through an incredible innovation during this period of time, which
Right. The electric
probably,
motor
probably
is,
part of the reason you gained a certain leadership, you know, in the 80s, 90s, right?
well, the electronics that we talk about for controlling motors would okay, the motor itself, Ron is saying, is basically the same as it was in 1888 when it was the motor was invented by Nikola Tesla. Okay, 1888. Well, yeah, it basically was the same motor. There was improvements. There were improvements in materials and other things, but the design was really still pretty simple. And that simplicity is what made it such a universal product to use. It made it. It was like you didn't need a lot of variations. The ball bearings or the bearings were a key issue.
Mhm.
And you know, but it was a simple beast, and then the controls now gave you was like putting a automatic transmission on your engine. Okay, so that's
Yeah.
kind of what, and it gave you a
Right.
lot more you could do with that.
Well, if you can, Wally, briefly tell us how variability in speed is so important to the industry and why it had such an impact.
Well, there's a lot of reasons. I'll start with one that's a kind of an obvious one, but it is not always the motivator, and that's energy efficiency.
Okay.
In centrifugal machines such as air fans, large fans, any fan for that matter, pumps, centrifugal pumps, the horsepower varies by the cube of the speed to drive that load. So for example, if you run a pump at half speed, then the power required will be 1/2 cubed or 1/8 the power needed to operate it at full speed. So
Okay.
what you've got here now for centrifugal loads, which are a lot of high horsepower loads in industry, is a way like a dimmer switch. Think of it like a dimmer switch.
Yes, okay.
Now. And by
Right.
turning the speed down, you greatly reduce how much horsepower it takes. So what you find is that the design of many pieces of equipment are oversized just due to conservative engineering practices. And you start to find that a motor is 350 horsepower, and you can run like at a cement plant kiln over at Riverside Cement, for example. When that plant was in operation in Riverside, California, that was an example where on what they call the white cement plant that made specific white cement for swimming pools and plaster, that you could run it down to 75 horsepower load and deliver all the air that it needed.
Okay.
So the previous so energy conservation happens to be one element. The other is better control of the process, eliminating the throttling devices. So let's say you have a fan that's got a 350 horse motor driving it, but you only need 75 horsepower worth of air. Well, the throttling devices eat up and are a source of inefficiency. It would be like saying your transmission. Think of it this way: if you were driving your car with your right pedal, the gasoline depressed
Completely
fully,
down.
and now you controlled your speed with the brake.
Yeah.
Okay. If that's what you did, then all of that energy that the brake is burning up and burning your brakes up
Yeah.
is wasted energy. So
got it.
that's one area. The better control, the idea of what we call fingertip control of the process. At the golf courses, you'd hear these superintendents raving when we introduced this to say, gosh, I can control the water pressure for our golf course sprinklers to 1 psi. So a 100-pound system, you could control it to 1 psi with a little knob potentiometer, and it was to them it was like miraculous.
Right. Got it.
So you were replacing what other devices, and those devices happen to be the highest maintenance device in the place. And,
Right.
and you needed a Ouija board to be able to change the pressure at the same time. They were
Right, right.
perfect. So here
Right.
was, so this is what the electronics can do. It's
Yeah.
sort of like delivering some wonderful things for control.
So what I wanted to say here, Ed, did you have a question?
Well, my question is related to the family more. How did you decide who was going to be the president, who was going to be the CFO of this company that you put together?
You know, it was we had an unusual. My brother and I are when we say identical twins. We had a somewhat of a strange relationship. My parents were out of the picture pretty much by the late 70s. My mother became ill. My dad took care of her, and he really never could get back into it once she passed away. He tried, but just didn't have it in him, in his heart. And so he left around 1980. We did buy his stock in about 1984 or 85. So he was formally out of it at that point. And my brother and I we were not possessed with what you call some sort of pride of ownership or something where we had a conflict. The president thing was, you could say, a flip of the coin. The idea of that. The CFO thing, though, my brother tended to gravitate to the chores that he had. He gravitated to the bill paying, the signing checks, that sort of thing. And we had a bank business, a separate, wasn't part of Brithinee Electric. We were founders of the Desert Community Bank up in Victorville. We started that in 1980 and sold the bank in 2007 to East West Bank Corp in Pasadena. And that was an example. You know, he liked the finance side of that more than, you know, so that's kind of how it gravitated. It was not really, we weren't hired for the job. You just did what you felt comfortable with.
Did you both own 50% of the company? And then if that's the case, how did you make decisions?
That's a good question. Because we didn't agree on everything. If you look at the background of my Zoom background and you see it looks like a blue sky, I don't think that Don and I could look out and agree that was a blue sky. So we had quite a bit of huh?
That's typical.
Yeah,
That's not unusual.
No, so what we did was, and by the way, Ray had begun this some of the questions with, was I in the motor side? Actually, I was in the control side, and we were losing money in the way when we were looking at our accounting. I became chairman of the engineering committee for our International Trade Association in 1990, in June of 1990. And I was in the control side of our business. It was growing exponentially. But I saw that the repair side, there was a case study done by one of the professors at Cal State San Bernardino. It was her first published case study and it was done on our company. And I was quoted, I think our repair business was 25% of our revenue. And I said, I can only picture it going down. Now that's one of those quotes that did not come true because the repair side actually went up and became, when we sold the company, was more like 65% of the business revenue. Wow. But what happened in the 90s, I got involved with this engineering committee work, and my helper in my office, who was married to a mechanical engineer, laughed her head off when she saw I got in the mail that you have been appointed chairman of the engineering committee. She said, "You're not an engineer. You're not like one of those engineers at all." To her, she was married to an engineer, and for her mind, it was the what do you call it? You put the pen holder in your pocket and and a slide rule, and to her that was, she says, you're not doing that. Well, I got immersed in it. I got handed some pretty big tasks, and the United States, well, in June, I got appointed to that role in June of 1990. What happened, I always will ask, what happened in August of 1990? Well, Saddam Hussein invaded Kuwait, and that initiated the first Persian Gulf War. That really impacted the electric motor business, as it did many other businesses, but the electric industry and electric motor business was greatly impacted by legislation that came out in 1992. And so we had to change our ways as an industry, and I was kind of in that part of the process. And so by that point, I saw our financial statements and how the motor side of our business was very busy, and we weren't making money at it, and that bothered me. So we divided it. We looked at it. So I said, I'm going back into the motor side of the business and see what we can do to raise the profitability of that portion of the business, and also to make it grow. There was no lack of business. It was not an issue of, gosh, I don't know, there's no business out there coming in, we can't really, I guess I'm watching too many Netflix movies. I saw one the other day where it was a comedy, and these guys were going to start a trampoline business. They said, trampolines? How are you going to get people to come in and jump on trampolines? And that's a business. The motor business, we didn't have that as a problem. There was plenty of business, but it was the question, how do you make money doing it? And so there were things that I saw that needed attention. And so and innovation that we brought into the picture after that. So anyhow.
And then you also had, about that time or a little bit later, you also had a pretty big scare from China and Brazil with the new idea that repairing motors might go away, because motors would just be so cheap, you just throw them away and have new ones. And it didn't work out that way, but I know you were a little concerned about it that's when we started working in the late 90s.
And that's kind of the way people characterize the business. It's like, well, gee, isn't it just a replacement? It was going to become a replacement business. Again, I was very fortunate. My activity in the trade association in the 80s, in 1980, I was a witness in a case at the International Trade Commission, a dumping case against motor manufacturers of Japan. And our big line of motors was Toshiba. And at that time, in the 70s and in 1980, they did not manufacture in the United States. They had plans and actually to manufacture in the United States. But what I saw was, the concern at that time was motor manufacturers of Japan. Now, you mentioned Brazil, you mentioned China. It wasn't that China, so Japan really dominated the mix in terms of upsetting the marketplace. Yeah. There were, at that time, if you look at your automobiles, similarly, you had Toyota coming along, Nissan or Datsun at that time, right. and they were cutting into what was the American market for autos, and there was a perception of quality problems in American manufacturing, and that wasn't just in automobiles, it was also in electric motors, and so people said, gee, why can Toshiba make this motor? And so the Japanese did a really fine job of introducing high quality products long before China was in the picture. However, even in 1980, one of the attorneys in that case asked all of the roughly 30 electric motor manufacturers in the United States at that time, and that's a far fewer number today, do you import product and put your name on it? And every single one answered yes, even names that none of us would have thought so, like Alice Chalmers. We would have thought, well, Alice Chalmers is an American name, as going back so many years.
Yeah, right.
Every single one was already lining up other sources for their putting their nameplate on. And but China was one of the people in the background, and some did a decent job with working in the Chinese manufacturing, and Taiwan was another factor. Some did a good job. The Toshiba eventually did manufacturing, but they did manufacturing in the United States, and that was the other thing. They were committed to build a big plant in the United States. TECO, which is a Taiwanese electric company, bought Westinghouse motors, and they had a big plant in Texas, for example. So these foreign manufacturers were coming in and building product here. In fact, the agreement in the dumping case was that Toshiba would not import any product from Japan. In fact, it basically threw a chill into any product coming from Japan into the United States, in terms of electric motors. It basically stopped it, because I'd have to go into the mechanism, but when the International Trade Commission makes a ruling, and it ruled against the motor manufacturers of Japan, said they were selling at less than fair value by 6%, which doesn't sound like a heck of a lot. But the problem was anything special, anything that fell in that product range that was going to be that was sold in the United States, when it cleared custom, would initiate an investigation in Japan to try to create a market value of a product. So it could be that the Customs Department, which is part of the Department of Commerce, would end up assessing a tariff a year after the product actually was imported. So the Japanese, and we had people from Mitsubishi come in the office. They said, "What's going on here? This is going to put us right out of the business in the United States." And so it did. And I remind people that law and those agreements are still in effect. You will not see motors made in Japan, 500 horsepower, 300. You will not see them in the United States anymore. They won't bring them in, because it triggers this investigation and then a reassessment of the value and the fair value. So it threw a real chill on that. That's why you don't, so then what? China wasn't part of that. In fact, later, when GE was lining up sources in China to sell its product, to build product under the GE label, Toshiba threatened to file an anti-dumping suit against General Electric. It didn't happen, but that was kind of the trade war mentality that was going on. And so as far as businesses go and the imported product, even in the United States, the manufacturers here came to the conclusion in the 80s that if you had the old days of large product orders was just not going to happen again. More than 50% of the product that most of them sell were special. They were not really vanilla catalog items. That was the salvation for American manufacturers.
Well, and that really, I think, turned out to be the case too, wasn't it? Is that your business continued to do repair business on existing motors because they fit a certain machine, or that wasn't made anymore, or you couldn't. You'd have to retrofit a bunch of the connections in order to get it to work. So it was actually a smarter thing to. At least that's what we were trying to sell, is it's a smarter thing to simply rewind your motors so that it is better than new. And that seemed to resonate. And I think that's where the business still is. It'll be interesting to see with all this automation, and if we have a manufacturing transformation, maybe there'll be more of a turnover of new motors. But the big equipment takes years and years and years. It would be funny to be on the floor and take a look at this big old thing, that was maybe done in the 30s, still running. All it needed to do is just be rewound and put right back out on there.
Right. Well, first of all, electric motors, an insulation system on a motor that's not used on a variable frequency drive, but on sinusoidal power, the insulation system has a L10 life of say 20,000 hours. So that means what we call the average life of the insulation system is 100,000 hours. That's 12 and a half years.
Yeah.
And it's not unusual. That's a statistical measurement or a statistical life. So it was not unusual to find motors 20, 30 years old, 50, and then occasionally you'd see one coming in that you could tell was factory original, 50 years old. And that's how long they last, a long, long time. The electronics tends to shorten the life when you apply electronics power supplies to motors. And that's another issue that we had to tackle. But I'm digressing here. What was your?
Well, what I was interested in is what do you, from your perspective, having been in this for 50 years, Wally,
Yeah.
what was more challenging or exciting for you, being able to shape the industry or being able to work in the production?
In my mind, I saw that both were necessary evils. I mean, in other words, I felt good about working with the industry standards. Our standards of the industry were ramshackle. Our we had an office in St. Louis for the Electrical Apparatus Service Association that was an unknown to the world. That was another, and so by tightening that up, we would get inquiries from the Navy or from, and we had really poor responses went back to them. And so this is what was handed to me to straighten out and write standards that would become the national standard.
Wow.
And so we did that in 1992. They were agreed to by the board of directors of our trade association. And then by 1998, we had worked that through the ANSI process, the American National Standards Institute, and that then became an ANSI standard. So that's what we needed. In other words, we had, as far as I was concerned, we had an industry problem to have to straighten out at the same time. And I really enjoyed that part of it, because it did also give us entree to meeting people who helped us with the innovation part. Not everybody took advantage of the innovation. One thing different about Brithinee Electric, we never did hide or tried to hide what we used that gave us the zero failures. It was.
Now, are you saying you shared it with other people in the industry, or
sure? Yes. From day one.
To my dismay, I might add, I tried to get them to keep that secret. And here we were literally publishing all of the secrets to how you increase the longevity of a motor and the efficiency of a motor, how you actually do that well. And Wally's out telling the entire world how to do it.
Well, and
the interesting thing is that hardly any of them would do it because it costs more money.
Well, yes, you have to keep in mind. We're quite different than other kinds of manufacturing where, let's say like in the electric motor manufacturing process, the labor content to manufacture a small motor, like a 2 horsepower motor, let's just say, is 15 minutes of time. Whereas to repair that motor is, let's say, 8 hours of time.
Yeah.
For the repair process. So our costs, our materials costs are pretty insignificant compared to our labor costs. In manufacturing, the manufacture of these mass-produced motors is the other way around. Their materials costs are the high part. So for them, the idea of taking a special wire like we used, and it was like, wow, wait, what am I going to do that for? What we found, because we did a lot of experimenting, if you want to say, Thomas Edison was a good experimenter. He would test filaments for light bulbs, try to figure out what would make a good filament. Where Tesla was a theoretician. He did this in his mind. He invented the motor in his head. But Edison was an experimenter. Well, to verify for us what was going to work and give us zero failures was experimenting. So we had to do some experimenting, and we came up with certain materials. And the key element was probably the breakthrough for us was the magnet wire coating. And we worked with the largest magnet wire manufacturer in the world, and they produced a material that gave us zero failures.
Wow.
Okay, here's some since you are dealing with marketing and you as part of some of your classwork, I'm sure. We had marketing gurus who studied our industry, and they found that we were in an industry that's what we call a zero strikes. You live in a zero strikes or one strike and you're out.
Right.
No,
One strike.
you weren't allowed more than one strike, and you were thrown out for years from your customers. So a failure I will say in the manufacturing arena, a General Electric, an Emerson, these very large companies, they could have failures, and their salesman could go back in and they'd still sell the next product. A repair shop, it never happens that cleanly, and it's like, well we're going to try somebody else. We're going to go somewhere else.
Right.
We did not. We had to live with this strange issue that our market is a one strike and you're out market. And so we were experiencing, prior to the 1992, we were experiencing, let's say, a failure every month and a half to 2 months. Now, we were doing 2,500 motors a year, 2,500 motors in a year, and one failure every 2 months, that's about 6 in a year. But it wasn't just to lose a motor that you have to rewind it again. It was that you lost a customer.
Right.
Well, and of course the factory, the water district, whoever happened to be using that motor, they got shut down, and so it was a catastrophic failure to them. It might have just, you could kind of characterize it as, well, it was only 6 out of X number, but for those 6, it was 100%.
Well,
this machine doesn't work anymore. And so they took it a little harder.
To give you an idea, and this is a strange market condition, but we were a warranty station for lots of probably a dozen motor manufacturers. Mm-hmm. And one of them makes vertical pump motors for the water industry, and the motor manufacturer, let's say on 400 horsepower motors, I'd look up in our very good record system, and you'd find out our biggest customer was X motor company manufacturer. They were the ones who repaired the most of those motors for. We actually did those as warranty repairs, and we had water agencies that would call and say, I see your tag on every single motor here in this pump station.
Having been repaired,
why did ours work? And the manufacturer would send it to us as a repair under warranty, and these are major dollars. And every single one now has been repaired under warranty. That does. I don't know how that they could exist with that, but I assure you, the next motor that pump a water district would buy would be from that same manufacturer. We would not have survived if ours failed like those did. Okay,
right.
I just would bring that up, and so we had a different challenge, and in places like, I'm going to bring a name into it, Disneyland. Disneyland is a high-profile, gold-plated type of company.
A lot of water over there.
A lot of water handling, a lot of air handling in their hotels and all over the place.
And machinery. Yeah.
And so our work there, the manufacturer said, when theirs failed as warranties, we would rewind them, and the customer said, yes, we want the Brithinee winding. So that
Right.
I mean, it took we had to deliver product that exceeded what the new product really was. Was that clear? So and then you have the customer for life at that point. I mean, you really it's a good feeling when you get to that stage. But it was not workmanship. I was watching some of your training videos or your Three Amigos videos on employee adding employees on. How do you onboard new employees and such?
Oh, yeah.
Advertisers all over the place would say, "Oh, it's the employees that's what it's the employees that make all the difference." Good employees make a good deal of difference, but in our trade, we had to get at the material side as well. We had to change what the industry was using.
Yeah.
And to get down to zero failures, we had to get at the building blocks, what we call the building blocks of quality. And while our employees did wonderful work, I would not deny that, it isn't only them, because until we did some innovative materials, we did not achieve that zero failure.
And let me jump in. We here I know we're coming kind of to our time, and I want to be sure to put this in, and it's appropriate a comment to your last comment, and that is that to really make this work from a market perspective, the quality was really, really paramount. And I've worked with very few companies where quality was absolutely the number one thing that had to happen. And on one hand, you have the real quality, but you also have the perceived quality. So Don and Wally told me when we started marketing all those years ago, now, if you think that we're going to lower the price and be price competitive, just forget about that. We have to charge more because it costs more. And so your job is to figure out how to sell these for more money. Well, that's where the quality comes in, because we really jumped on that and pushed it really hard so that everybody could know that Brithinee quality literally was not high quality. It was better than high quality.
Right.
But we could only pull that off because it was true. And that's a big part of the success of the company and becoming really the dominant Southern California motor repair company.
I realize we're at the end of an hour or so here, but I would like to say that while my brother and I didn't agree on various operational issues at times, we had our share of arguments. The one thing we did agree on was that our mission statement was to provide products and services of such quality and timeliness, that means with speed, as to raise the expectations of the customer. So that was our mission statement. The idea there was, and it was music to our ears when a customer uttered those words, was that your work has raised my expectations of what can come from your kind of business. And that was right in line with what our mission statement was, and we did really agree on that the quality aspect, and that's why things, when you're talking about the Malcolm Baldrige Award, there were other industry standards that came along, ISO 9000, for example, and we worked on producing those for our industry as well. But the idea was it quality. We wanted to raise the expectations of what the customer could actually get, and we're in a competitive business, so there are lots of people out there working lots of hours, giving what I call very good service. But we wanted to raise their expectation of what can come of that. So that's, and I think we did a pretty fair job of achieving a lot of that.
Well, I think you did. What I was going to say, to wrap this up, because we are an hour into this, Wally, given what you learned about shaping both the industry and your business and the customer's expectations, give us some advice as to what you would tell a young entrepreneur getting into business right now to help him from your 40-year vantage point.
60,
Well, huh?
60 years.
You should have sent me that by email in advance so I could have worked it up. I would say you want to find the passion in your work, because to do this takes, it's not just money, it's passion, and it's a lot of extra hours, and it's that extra effort. The societal part, the idea of raising the whole industry so that you're a thought leader in the industry. If that would be a phrase that some people used to use, you know. Our DuPont friends would say, people on the other side of the country ask, what is Brithinee doing? What are they using these days? Okay,
Right.
so I would just say you better be passionate if you want to get in it that way, and find what you enjoy, and then really run with it. You know, I think there's plenty of business out there. That's the other thing. We are not in that particular business is, well, people would say, it's a dinosaur business. It's we always said we want to be the last standing Tyrannosaurus Rex, and so it's fun. I mean, but if it isn't fun, then I would say you're not going to succeed. Go ahead.
I was going to add, Wally, it's not a dinosaur anymore, because we're going to have EVs all over the world, and they're all going to run on motors.
That's another story. Yeah, but I hope if we're done, I know you guys have a time limit on this. If you have other questions, obviously there are other aspects. The onboarding intrigued me. It's not a subject I'm good at, but it is a subject that as an employer you have to get involved with. Ray, we were involved with you in trying to write an ETP grant, if you remember, for training. So if you call me back, I'm tired of watching Netflix on the pen, and so as we come out of the pandemic, I'm getting more and more involved in other things here at the University of California. I've got lunch with some Chaffey College people next week. And so we've got some other things going on, but I cannot be involved in our business anymore.
Right.
But
well, you have a lot to give back.
Yeah.
well, I'm looking forward to that aspect. I do. I'm ready to tackle some more. Let's put it that way. But I think that enthusiasm is important, and I think that I really wouldn't know what to advise a young person, for example, of what you do with your life. Is to find what you really enjoy, and try to make that lead you in the right direction. Anyhow,
I'm just shocked about the company that you created and your ability to actually get involved and write the standards for that industry and to come up with a product that was so high in quality that it didn't break down. That's a remarkable story for this area.
Yeah.
I'm in shock. This is like a big company, and I'm surprised why this company never sold stock and went on the market.
well, and you brought up Cal State San Bernardino had a professor, Sue Greenfeld, who I think she wrote her first case study on us. Then she wrote one 10 years later. So by the mid 80s, she wrote her first case study. It got published around 1990. By the mid 90s, she did her second case study to get published. It was Brithinee Electric Revisited. And one reason I was very wanting to cooperate with her is to read, because you read these business student problems, and these were textbooks. It was published; those were published in quite a few textbooks, and so students would ask the same question, like, "Well, why don't you just clone this thing? Why don't you become like McDonald's and just start branching out and stuff?"
Like General Electric. I mean, just you're very similar to them.
If I were to say we were not good at partnering, we were not friendly to anybody who, in a sense of to partner, and it would have taken, to me, to do it right, it would take somebody buying us where you're part of the company. When we sold the company, we had inquiries, very serious inquiries, going back to 2000 and let's say 2009, and it had to do with the expansion. When we went through our last major plant expansion, it was very visible, and it takes you into a different league in terms of what you can do in that facility. And so the people that were mostly kicking the tires to buy Brithinee Electric were looking at us working yet. So in 2009, I was still, let's just say 60, 61 years old or something like that. But 10 years later, I had been in the hospital with a near-death experience, and I said, I can't negotiate now. So every year we were looking at, there were people wanting to buy us, in which we would be part, and I say we, my brother and I would be part of the continuing company. Strangely, Sulzer, who was the successful buyer, sort of a surprise to us was that they wrote us out of the business right off the bat. In fact, in capital letters on the contracts, you will have no authority. You will have no, you can only be a consultant. You do not speak for Sulzer. You do not, and they wrote us out of work in a sense, except for some consulting. Everybody else, we would have been involved. There would have been an earn out. There would have been, if you can, increase the business, blah, 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 and be sort of like part of the continuing business. Sulzer didn't do it that way. And so that didn't come about until after the quiet period. I don't know whether that's a term. I don't really remember what term our agent used, but there's a period where you cannot talk about the sale to anybody else once you kind of come to an agreement. And we hadn't seen that Sulzer was talking about us not being involved. So here it was. I did have a serious health issue in a year prior, and it was, it was still ongoing for me. Little did we know that my brother would have 2 years after the sale, that he would have another very serious illness and problem, and he's now paralyzed from the waist down, and is a very difficult situation. So the idea of by not making a sale in the early years, when all these people were coming in and, like, say, kicking the tires, it changed it to being, you're out of it now. And but I will say a larger company would be needed to do what the cloning.
Yes.
We didn't have the capital to really do it, and we didn't like borrowing. In our business, borrowing money, you have to have so much collateral. If you borrow $1 million, you got to back it up with
Right.
$5 million worth of stuff, assets or more. And so the idea of growing, we'll let somebody else do it. That's what I guess happened.
It would have to be a public company where you have shareholders, and that would be, that's the model now. That wasn't the model back then.
And these young people would see that, by the way, in these business classes. And I was getting inquiries from Australia, Russia, Saudi Arabia, that were using the textbook on Brithinee Electric. And one of the things that you find when you have a case study done, and it was done pretty well, we got published in a lot of textbooks, is that you start to find how quickly that whole, if let's say the market study, the first one was done in 1984, 85, by 1990, if you read that thing, you'd say, things have changed an awful lot in 5 years. The same went for the second case study. You start to see that the background changes rather rapidly. So even what's put into print, like for these textbooks for business schools, don't make the changing background, but at least young people do ask those questions, just as you did. Why didn't you duplicate it? Partly we were not good at acquiring the help and the finances to do that. And so we took the safe route, which is let's just make our living here with this facility.
Gotcha.
Well, Wally, we want to thank you for giving us this time. I can't speak for both Ron and Ed, but I think it's probably something that we could revisit again and look at it a little more and give you some time to think about some of these things. But
Sure.
it is an honor to have you kind of present what you did and how you literally transformed an industry. It's been a joy to have you here. Ed, Ron, do you have anything you want to add?
I
Or
think,
should we-
yeah, we're pretty well used up our time. It was great. So we're going to have to shut her down. But I do want to say that as Wally mentioned, he's gotten involved with and in some interesting ways, doing some training and some cross-pollination with businesses and engineers. And we ought to have another hour discussion about that. So let's just plan on doing that, and we'll say goodbye for today.
Very
Yeah,
good.
great. Thank you, Wally.
Thank you, Wally. Yeah,
Thank you.
appreciate it.
Yeah.
My pleasure.
And, that brings